I'm going to talk a little bit about some actual practical things that we can do to start putting some of these ideas into our research practice. So I mentioned here something about ODK. There's something about the way we use data in our ODK forms that can help the process. And then building your project database if you don't already have one. I'm going to talk a little bit about that. And that might sound a bit scary for a lot of people here. Trust me, it's less scary than you might think. So stick around for that. And then there are a couple of extra sections at the end that I want to highlight as a few other points about bringing it back to why data management is important for research, particularly around the ethical considerations and publishing considerations for research. So earlier in the year, Rick gave a presentation about how you create your research questions. And this was a diagram he presented about the research process. And the key points of this diagram is that research is a cycle. And he talked a little bit about this double cycle where you have the main research process, but as you're reflecting on your observations, you may be updating a conceptual frame. You may be changing how you view the systems in which your research works. And I bring this in here because I want to make the point that all of these arrows rely on good data management practice. And we'll explore a little bit about why that is. But the purpose of all of the nitty-gritty of managing data is so that this cycle can actually continue. And then again, earlier in the year, Dave Priest and the FIPS team gave an excellent presentation talking about the research data lifecycle and their experiences going through this lifecycle with different iterations for their project. And I want to present both of these cycles here because I don't think they're often shown together. The research data lifecycle and the research lifecycle are often considered quite separately when in this sort of high level thinking. And sometimes that's good. There's a benefit to thinking in a focused manner. When you're thinking about your research questions, you want to be contextualizing your study within the broader scientific understanding of the systems you're working in. And when you're thinking specifically about your data, you want to think, how is your data used in the planning and design stage? What data are you collecting? How are you processing your data? How are you storing your data? How is your data being reused? And how are you using other people's data? But I want to just show them here together to kind of connect these ideas in our minds. You can't quite map one section to one section, but they are describing the same process, the same cycle from different aspects. And then thinking about all of this, there's a lot of questions that can come out of this quite high level thinking. So in all of these research flows, you start with a research question. Well, you start by coming up with your research questions, which is a whole other presentation. But once you have your research questions, you organize some data collection perhaps. Then you collect your data, you process your data, you review your results, and you share the results. And the cycle continues. And there are lots of questions that you can ask about these different steps in the process. So the first question is, where did your research questions come from? Are there existing relevant data sets that relate to what you're asking about? And if there are, should you be linking new data that you collect to these existing data sets? And that can be quite hard if the data sets belong to other groups or other people. But maybe it isn't so hard if the data that you're referencing is also part of your project's data sets. Then the question of what data do you actually need to answer your questions? This is a question that you've probably been asked quite a lot by members of my team. We like asking the questions about, why are you collecting this piece of data? Is it useful for you for answering your research questions? And then there's questions about the collection methods, which leads to questions about the format of your data. And what is the purpose of the data that you're collecting? Are you going to use it immediately for analysis? Are you sharing this data with others? Are you storing it for long-term use so that the cycle can begin again later on? And these might involve different formats. So that's trying to put things in the context of research. And now I'm going to change tracks slightly and focus on good research data management instead of good research data management. And the first statement I have here is, good data management is like housework. It's like having, it's like organizing your physical space. The question here, do you know where the cutlery is in your house? How do you know where the cutlery is in your house? I've chosen this example because to a lot of us, this is quite an obvious question. Well, of course it's in the kitchen. Of course, the knives and forks are in the cutlery drawer, or in the cupboard where you store all the cutlery. But how do you know that? How is it obvious? And if someone else came to your house, would they be able to find your cutlery? Would they be able to figure it out? There's a convention that you store the cutlery that you're going to use in the place you're going to use it, which is the kitchen. So data management should serve a purpose. There's a reason for putting the cutlery in the kitchen and not upstairs in the bedroom. And for research data management, your data management should support the research that you're doing. And there's a key point, which is you may not need the same organization system for different purposes. I mentioned before, initial analysis, sometimes you want to use your data immediately. As soon as you finished your data collection, you finish your survey, you want to analyze it. So that means the data has to be immediately accessible to your team. And it has to be in a format that is useful for analysis. But maybe that format is not the best format to store in the long term, so that you can find it again in 2 years' time when you need to refer back to your results. And using the housework example, cutlery that you use for immediate use, well, that's stored in the kitchen, most likely. Maybe you want to organize your cutlery in a slightly different way if you're sharing it. Maybe you're taking it somewhere out. You're going for a meal outside, or you're going for a picnic. You want to organize your cutlery in a slightly different way. And then maybe for long-term storage, you put your cutlery away in large storage boxes and put them in the back of the cupboard somewhere. These are different ways of storing the same thing for different purposes. So your data management should serve the purpose. And we don't have time in this hour to go into details about exactly what formats are best for these different purposes. But it's something you should be thinking about. And towards the end of this presentation, I'll give you some pointers to start thinking, if you haven't already, about data management in this way. So I want to now move on to a point that has come up quite a few times. I've noticed this, my colleagues have noticed this, and it's a very important point relating to data management, and that is the use of unique IDs for different things. And I want to just pause for a moment here and play a quick game of spot the difference. What you're seeing here is an example of surveys. I've made this example up. I've taken inspiration from a few real examples, but this is a completely made up example of an ODK form. So those of you who are familiar with ODK will recognize this as a choices worksheet, listing different choices for selecting the location of this survey. So you start off by selecting the cluster, then you select the district, then you select the sub-county, and these are locations in different parts of Uganda. And I want to pause just for a minute or so and ask, can anyone in the chat write in any differences they see between these two surveys? And if you can spot the most important error in the between these two surveys, because there is a very important issue here that I want to discuss. So I'm just going to pause for a moment. Okay, I'm not seeing anything in the chat. Maybe it's a little subtle, and you don't have the context of this of this particular survey to really spot. But so what I want to just show, look at the list of clusters. In 2019, this survey was only conducted in 3 clusters: the South Central, the East, and the West. And each cluster had, in this case, 2 districts where the survey was being conducted. And so South Central is listed as cluster number 1. This has this here is the value, so it's the ID value of this cluster. Number 2 is the East cluster, and number 3 is the West cluster. Now in 2021, this team expanded the survey. They also wanted to survey a group in the north of Uganda. So they added a new cluster and they added some new districts. So now they have the north, the east, the south central, and the west cluster. But notice what has happened to the names of each cluster. In 2019, cluster 1 is South Central. But in 2021, cluster 1 is the North cluster. And then the East cluster is cluster 2 in both cases. But in 2019, cluster 3 is the West, and cluster 3 for 2021 is the South Central. And I want to just take a moment to emphasize this, because there will be some of you here looking at this and going, yes, this is obviously not great. There'll be some of you looking here going, but what is the issue? Because in both cases, if you take 2019 on its own, everything checks out. The districts that are meant to be in South Central are linked to the South Central district. And here, the districts that are meant to be in South Central are still linked to South Central. These names have been updated. So each survey on its own is consistent. And if you run the survey in 2019 here, you collect data, you analyze that data, you come up with some results. Great. In 2021, you run the survey again. You collect the data, you analyze the data, you come up with some results. Great. And this issue here only comes up when in your project you take a step back and you suddenly you decide, well, can I now compare my results from 2019 with the results from 2021? And that's quite a common thing you may want to do. If this is the same survey, you're surveying in these three clusters, maybe you're even going back to the same groups of farmers and asking the same sets of questions. It could be a very useful thing to be able to compare the answers that farmers give in 2019 compared to this year. But when you try to compare them, you suddenly find that you can't reconcile the locations of each record. You say, okay, give me everything in cluster 1, and suddenly you have South Central and North in the same filter. So then comes the task of unpicking this. How do you match your locations together? Maybe you can match by the label, but maybe not, because maybe the labels were entered slightly differently when you came to redo the survey. It becomes quite a challenge when you have the location data in this type of format. And this is something I have seen quite a lot, and my colleagues have seen this sort of thing as well. This is a kind of, I guess, a simple example because it's only about location data. But what if these lists were the crops grown, or the types of fertilizer used, or something more detailed in your data set that then takes a very long time to untangle if you want to compare between these two different surveys. So what's the solution? I mean, one solution which I dislike is just review the previous survey when you're making the new survey. Try not to make this error. That's one way of thinking about it, but I don't like solutions that are just try and do better, because we all make mistakes. It's so easy to end up with this sort of thing. So the solution, at least using ODK, is to take your location data out of the main survey. So you take it out of the XLS form and put it somewhere separate. Some of you will know about how to use a CSV file as an external lookup when you're creating an ODK survey. Some of you won't know about this, and when we share around the resources for this presentation, we'll make sure to include links to some tutorials to help you understand what I'm talking about here in the practicalities. But the theory is that if you remove your location data out of an individual survey and put it in one central location, you can have this CSV file, which stores all of your location data. And this isn't linked to a particular survey. It's not specific to the 2019 survey. It's not specific to the 2021 survey. And if you then add additional locations, you can add this to this one central location. So when you come to do a 2022 survey, you will still be pulling from the same locations with the same sets of IDs. And so you would have your location data in this CSV file. You would link this CSV file to the ODK form. And then in your ODK choices list, so this is the same section as from before, but now you're only referencing the column headers here, and you don't have the actual location data in your survey. And then just to finish this section, showing how you do this briefly in ODK, there's with the survey sheet, instead of doing the sort of cascading select, instead of filtering in the choices sheet, you add some filters into the appearance. Again, I won't go into details because we don't have time and because there are other resources on this. So if you're interested in learning better how to bring an external data set into an ODK form like this, watch out for the resources at the end of this and that will be shared after this seminar. So at this point, I want to pause for a moment because we've done a couple of sections now, and ask if there are any questions so far.
So Angela would like to know how you can link two sheets of data.
Angela, is that linking the two sheets as in linking the external CSV data into the ODK form?
Yes.
So so there's two parts to it. The first is in the actual ODK form, so in the Excel file within the survey sheet, where you have your select questions. There is this syntax. It's under appearance for some reason. I'm not entirely sure why, but it's there. So if you use this search function, for this example, locations is the name of the file that that you want. So you would have a locations.csv file. And then here, when instead of looking for within the choices sheet, it will look within the locations CSV file to find the options. And you see in the choices sheet for the ODK form here, the list name clusters, and that's actually a mistake that I've noticed here. There should be clusters, but see, it's easy to make little mistakes like that without testing. But the name and the label here are the column headers in your CSV file. So this is looking for cluster ID and cluster. And then in the CSV file, there is cluster ID and cluster. So this column B here would be the label, and column A would become the name, so the value that is stored. And the way you actually link them together, so when you deploy your ODK form, if you're using Kobo Toolbox, you would upload this CSV file as a media attachment. And I can just very quickly show that to you now. I can find just a random example here in Kobo Toolbox. So I will find an example here. Any forms that you have deployed on Kobo Toolbox, if you go to the settings and you go to media, this is where you can upload those CSV files. And you can have one CSV file, say for locations. You can have lots of CSV files linking to lots of different questions. So you can see here, this one has a lot of different CSV files attached, which all have different lists for different questions. So, Sabina Beatrice, you have a question. Why should we link new data to the existing data if at all the objectives of the surveys varied? That's a good question. Sometimes you will change your objectives as you do different surveys. And so take the example here. Maybe your different surveys serve different purposes and you're looking for different results. So you're asking different questions in 2019 to 2021. And so in that instance, maybe you won't need to link the data sets together. Maybe it's sufficient to answer one set of questions with this survey and another set of questions with this survey. But I would ask the question, do you know for certain that you will never want to look at the results from one survey and the results from another survey together for for certain locations? There's quite a big assumption there that that you will never need to connect these data sets together. And actually, there's a growing, at least my understanding is there's a growing desire for what are called like meta-analyses. They've been quite popular. Well, at least I've encountered them a lot more recently. Those of you in the those of you here who are more familiar with kind of the research, kind of the research world, probably know a lot better than I do how popular meta-analyses are and how useful it can be to be able to pull together data from different sources into the same data sets to generate new results. Often you will ask a question and you will find that you can already answer that question with data you have already collected. So maybe you don't have to collect the same data again to answer that question. And it's much easier to do that if you have the same sets of IDs for common elements in your data sets. So common elements are particularly locations, or when working with farmers, a farmer ID, perhaps. FIPS, the presentation with FIPS highlighted quite a challenge of working with large numbers of farmers and collecting different pieces of data from farmers and not wanting to take up farmers' time by asking the same questions again and again. So that's quite a long answer to your question, Beatrice. I hope that was hope that answered at least part of your question. Isuf, if you delete a project from your ODK account is there any way to recover the data of this project? So I'm assuming you mean in Kobo Toolbox, and the answer to that is no. Which does actually lead on a little bit to something I'm going to discuss in a little bit, which is building up your project's data sets and bringing your data together into a location that's good for long-term storage. Because really, Kobo Toolbox or your ODK system, it's not a good place to store data for the long term. It's great to collect data, but once you've collected it, you should be extracting this data from Kobo Toolbox and storing it somewhere else. And so I'll get onto that next point shortly. Okay.
Thank you.
Great. So I'm going to skip on now to the next part of the presentation, and I want to talk briefly about this about a question that probably a lot of us have, and that's where to begin thinking about the project, the research lifecycle and the research data lifecycle. When you start thinking about your project data, where do you begin when you're planning new research? And it's very easy to start with the question, what data do I need to collect? And most people here, I think most of us are aware that this question is not the best place to start, even when you're focusing on data management. Questions that there are questions to come before what data do I need to collect? And this include, okay, what information do I need to answer my research questions? What data do I need to generate that information? And then there's a critical question here. What data might I already have? Because if you already have the data you need to answer your research question, maybe you don't need to do any data collection. Maybe you can save that time and effort. Data collection is often expensive. It often takes time, and it's a limited resource. So the better use you can make of data that you may already have, the more value you get from the times when you do actually go and collect data. And it also allows the data collection you run to be more focused. Instead of asking the farmers the same sets of household baseline questions you've already asked them in previous years, maybe you can link the new survey to the existing data set that you have and only ask new questions that are relevant to your particular activity. So what data might I already have? That can be quite a hard question to answer. And so I'm going to talk a little bit now about how to answer that question. Because for some projects, it's actually quite difficult. And I mentioned at the start that I think your project needs a database. And I don't think that is necessarily what we consider as a database. So a definition of database I found on Wikipedia is a database is an organized collection of data stored and accessed electronically. Okay, an organized collection of data. That's actually quite broad. Usually when we think databases, we probably think, oh, it's a relational database. Maybe it's an SQL. Maybe it's something like a MongoDB or a CouchDB or one of these complicated systems. And maybe if your project is big enough, you could think about something like that. I think almost every CCRP project probably needs a slightly less complicated system. My suggestion is a set of organized files and folders. I wanted to highlight this comment because I think it's important. Organizing your data is essential, regardless of how you organize it. I know a few projects have started thinking about this or have been thinking about this for quite a while. And I wanted to try and give a few ideas on where to start with this process, because especially if the project has been running for quite a while, it may be quite a daunting prospect to try and organize all of your project's data. So I want to go through a few questions. And to start with, some relatively basic questions. First thing, does someone in your project actually know where all of your data is? Hopefully, yes, but it might not be the answer might actually be no. And if the answer is no, then who knows where different parts of the data exist? Does more than one person have access to all of your data? Well, that's a slightly more complex question. And I ask it here because if only one person has access to some critical data about, say, your recent survey, if one person has access to that data and that one person leaves, then who's left to access that data? Having two people who know where your data is and who can access it is good practice to ensure your project can actually continue to get access to the data. And then the next point, is it stored safely and securely? Is the data backed up somewhere? Is it secure against external access? Do the right people have access to it? And do the wrong people not have access to it? So those are some questions to get you started thinking about this challenge. And then what's the actual process? How do you, once you've answered some of those questions, how do you start bringing your project's data together? And if your project is quite new, if you don't have a lot of different activities that you have done over the years, maybe this is something you can start and do quite quickly. I know for some projects who have been going for quite a long time, this is a very difficult task. So here are some suggested activities. First, map out your project activities. What activities that have generated data has your project actually done? And this could be a combination of actual proper data collection, I say proper, things that are considered official data collection activities, surveys, interviews, experiments. Has your project searched and found secondary data sources? Maybe your project involves looking at climate data, and so maybe you have used data from Met services in the past, and you want to either keep the data that you've used or keep a reference to the data that you have used so that you can go back later. Not included on the slide, but there is also data that gets collected that isn't a rectangle of data, that isn't a sort of standard survey responses. We've done presentations in the past talking about qualitative data and what counts as research data. A photo could be research data. the notes that your field team makes when having a informal conversation with farmers in your project could be project data and should be considered in this activity. So after you've mapped out the activities that your project has conducted since inception, you can go through each activity and try and find the data from that activity. Does your project still have it? Hopefully yes, maybe not. If you do have it, who has access to it and where is it currently? It may well be that data from different activities is owned and managed by different people in different places. So before you build your kind of central location, your central storage system, maybe you want to understand the scope of your project data in this way. And then what I'd recommend is actually bringing your data together. And there's two important points to this. Firstly, you need metadata. You need to understand the source of each data set. Which activity, how was the data generated? Where and when was the data generated? Who generated it? Metadata is important to let you understand where the data came from and to show that it is actually valid research data. And the other note is that you don't need the perfect system before you can start bringing your data together into the same place. As I mentioned, this could be a long process. This could take weeks or months if your project has been going for 10 years and you have so many activities and so many data sets in different places. So bringing everything together and making sure that every data set has a good amount of metadata will give you the breadth of your project's data sets. So now you can see what data you have. And at this point, you might want to start reorganizing it. You might want to start thinking about what are some specific use cases for your data sets. Just now we were discussing the idea of meta-analyses. So maybe it's important to organize your data so that it's easier to do these sorts of meta-analyses. So how are you going to organize them? Are you going to sort by activity? Are you going to sort by date? Are you going to sort by location? And this will be different for your project's requirements and needs, but a suggestion just to get you started. There's two big purposes, and there's long-term storage where you want to keep data for a long time and so that you can reference back to it. And there's data that you are using currently for current activities or current analysis processes. I would suggest thinking about it in this way. For the current data sets, perhaps think of it by activity or by purpose or maybe by research question. And for long-term storage, try thinking about it by data subject. So instead of storing all of your survey data by year, maybe you can extract out your location data and store that. So you have your project's list of clusters and the districts in which you work, and you have a locations data set. Because then you can use that data set for new activities. You can reference back to it, and you can update it as you go. So you can add new locations as your project expands into new areas. And you can do that in this central location to avoid some of the issues we mentioned before. So this isn't the complete guide to centralizing your project data. There's a lot of other issues to consider, but hopefully this gives you a starting point for if you haven't considered this in your project yet. It's worth spending some time on this. And before we finish, I wanted to mention just a few other points. So far, we've talked about data management and how it is important internally to your project. There's also a lot of arguments in favor of taking care over your data management when your project interacts with others. So the external reasons for good data management. Carlos, in a previous seminar in this series, gave a talk about what it means for your research to be credible and considered valid. And there were lots of points about the meaning of how can you consider something to be credible? What does it mean for your research to be considered valid and to have good validity by different groups? But for this purpose, I want to just highlight a relatively simple point that good data management is vital to show your research outputs are credible and valid. When you present findings to a publication, to peer review, a question that will be asked is how you have managed the data, how you have made sure the data are accurate and valid based on the statements you have made. And being able to present the plan that you made and and what you did to manage your data is important to kind of show this. Just taking from Carlos's presentation, credibility is based on a few different things. Carlos mentioned these 3 points: ethos, pathos, and logos. Credibility is based on who is saying this statement. How is the statement presented? And then what is the logic that underpins that statement? What is the weight of the evidence? And having good data management seems like it's mostly about the logic that underpins the argument. If you have good evidence, if you have clear and if your evidence is presented in a way where your data is clearly managed well, then the logic can be a good source of credibility. The weight of the evidence is stronger. But there's also an aspect of the others. How is your research presented includes how is your data management process presented. If people see that your data is well organized, they're going to be more likely to recognize and to see your research results in a better light. That's just how people work. Even if you're doing good data management, it's often good to show that you're doing good data management. And then following from that, data publications. Publishing your data often has a lot of requirements. And there are, well, different publications, different journals, different groups have different requirements for publishing, both publishing your research and publishing your data. And making your data open is a big thing now in the research world. It's often expected that you will make at least an anonymized version of your data available for review. And I wanted to point you towards the data tree course that is available and free online, developed by the University of Reading with a very long list of expert collaborators in the field. Many of you know about data tree from my previous presentations, but I want to highlight it again here. And particularly in the first module, there is a video about top tips for data publishing. And this is presented by the head of data publishing at Springer Nature, who has given that title, has a lot of experience in helping researchers understand the requirements and meet requirements for publishing data. And then finally, because we are running out of time, I want to briefly mention ethical considerations. And now I'm here, I feel this should have been near the start of the presentation, because ethics is always something that's vital, and it's often something that's squeezed in at the end, like I'm doing here. So I'm guilty of this as well. But data management is also an important part of demonstrating your adherence to good research conduct. The slide here is from a data tree presentation in, again, module 1, talking about the ethics of research data management. And there's talks about the principles of research integrity. And presenting your data management process in a clear way is a good way of showing that your research is conducted in an honest and transparent manner, and that we're acknowledging the contributions of others, and we're communicating methods, and we're complying with relevant legal and ethical requirements. And not included here on the slide is also the idea of data confidentiality. It's important when you're figuring out how are you storing your data? How are you managing access to your data? Do you have any confidential or private data in those data sets? And are you treating those data sets as confidential? Are you following? Are you how to say this? Are you treating those the confidential data with respect? And doing that is respecting the sources of those data. If you're talking to farmers, it's a way of respecting the farmers that you work with, or the other people that you work with.